Hi, I'm Toman Nahumi from DELL EMC. This video will show a demonstration of the DELL EMC VxFlexOS CSI driver on Red Hat OpenShift platform and a deployment of persistent cloud-native application on top of it. OpenShift Container Platform 4.2 introduces support for the CSI driver. This is a plugin that is installed into Kubernetes to provide persistent volume operations for storage systems. Kubernetes version 1.14 and CSI API version 1 are built into OpenShift Container Platform 4.2. As you can see, there are no pods running in the default namespace. Under the VxFlexOS namespace, you can find the VxFlexOS CSI driver pods. In addition, the VxFlexOS SDC driver is installed on the RHEL OpenShift worker nodes. Under the Storage Classes tab, we can see the two VxFlexOS storage classes which have been created during the CSI driver installation. Now, let's create a stateful application. For the purpose of this demo, I'm deploying a cloud-native database called YugaByDB, which consists of 3 master nodes and 3 worker nodes. Each has a persistent volume claim which equals to a single volume on VxFlexOS. I'm creating the application by running the oc create command and specifying the manifest file of this application. The VxFlex CSI driver is responsible for creating the volumes at the storage level, mapping them to the worker nodes, formatting them with a file system based on the application requirements that's specified in the PVC section in the manifest YAML file, and mounting the volumes on the pods. At this point, we can see that all 6 pods are up and running. We can also run the oc pvc get command to list the PVCs attached to these pods. By navigating to the VxFlexOS UI, we can see that the volumes have been automatically created and mapped to the Kubernetes nodes. We can also take a look at the pods and persistent volumes from the OpenShift web UI. Now, let's access the application UI using the Kubernetes service IP and port. We can see that we have 3 worker nodes, but they are not running any workload right now. So now it's time to run some load. I'm connecting to the master pod and installing some tools which will allow me to run CassandraDB key value random workload on my application. By going back to the application UI, we can see that the workload is being generated and distributed across all worker nodes. OpenShift UI allows us to see specific performance metrics for each and every pod, including memory, CPU, and storage utilization. We can of course see the load from the VxFlexOS UI as well. Now, let's scale up our application and create 3 additional worker pods. I'm navigating to the application manifest file and increasing the numbers of worker pods from 3 to 6, and then clicking reload and save. We can see that pods are being scheduled while the volumes are being created and mapped to the nodes at the storage level. Within a few seconds, the new pods are part of the cluster. The more powerful aspect of this solution is the agility at the application level. While the VxFlexOS CSI driver is taking care of the storage side, the load is being automatically distributed across all available worker nodes. This provides the user with the tremendous flexibility to scale his applications up and down to fit the performance need automatically and efficiently without the need to manually interact with the storage. I hope you will find this demo useful, and thank you very much for watching.